Welcome back, viewers. Now let's discuss alkenes as part of our study of organic chemistry. The reason why I've not been dropping video in organic chemistry is because I wanted to start from the beginning, and that's from organic chemistry for beginners. Watch out for that video. It's still loading. Now, alkenes are also called olefins. They are called olefins because when they react with halogens, they give us oily compounds, oleum, oily compound, and that's why they are also called olefins. And that is why the double bond in an alkene is known as olefinic double bond. Now, the general formula for alkene is CnH2n. All right. The first member of this family is, remember, unlike in alkane, where the first member, the number of carbon atoms start from 1. For alkenes, the number of carbon atoms start from 2. Therefore, if I put 2 here, I'm going to have C2H, 2 times 2 here will give us what now? 4. So C2H4, I will call this ethene. Some texts call it ethylene. Ethylene or ethene, same name for same compound. If I should draw the structure of this first member now, it's going to be like this: C, double bond C. Then at this point, we'll have maybe the 4 hydrogens. So H, 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 H. All right, this is how we draw that. And remember, in organic chemistry, we must obey what is called the tetravalency of carbon, which means that carbon must be surrounded by 4 bonds. All right, carbon must be surrounded by 4 bonds, tetravalency of carbon. So that's what we have here. Look at this carbon. How many bonds does it surrounds it? 1, 2, 3, 4. What about this one? 1, 2, 3, 4. That's tetravalency of carbon. Now, from secondary school days, we were told that the hybridization of alkenes is sp2, or that alkenes are sp2 hybridized. That's correct. And the bond angle is 120 degrees. Of course, sp2 molecules are 120 degrees in terms of bond angle. But it's important to state that these 2 bonds here, one is sigma bond, and the other is what? Pi bond. Pi bond written as pi bond. The other is sigma written as sigma. All right, sigma and pi bond. So in a double bond, one is sigma, the other one is a pi bond. All right, now, it is important I tell you, even though in secondary school we are told that alkenes are sp2 hybridized, yes, but it does not mean that every carbon atom surrounded by a double bond must be sp2. What do I mean by this? Look at this compound I want to give you now. C, 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 double bond C, double bond C. Look at this compound. If I should balance everything here, 1, 2, 3. There are hydrogen at this point. There is 1, 2 for that guy. And then for this guy, everything is complete. For this guy, complete. Then I'll have 1, 2. So remember that there is hydrogen at all these points. Hydrogen, 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 hydrogen. Don't want to write them for time's sake. Now, imagine an examiner asterisk this carbon for you now and ask you, what is the hybridization of that carbon there? Of course, if you just say, oh, there is double bond around it, therefore this carbon should be sp2, you are successfully going to fail it. That carbon there is not sp2, but what class? sp. So if you want to know why it is sp, in my next video, I'm going to do hybridization in organic chemistry. So you see how to determine the hybridization of each carbon in organic compound. So when we talk about hybridization in organic, then we are talking about hybridization of each carbon in the organic compound. We don't just say, oh, this is the hybridization of this structure, but rather we talk about the hybridization of each carbon in an organic compound. So now moving on now. So this carbon is sp because it has just 2 neighbors. One at the left, which is carbon, one at the right, which is carbon. You watch the next, do well to watch the next video, hybridization in organic, so you understand why that is sp. Moving on now, alkenes are sp2 hybridized, yes, and bond angle is 120. All right. The next thing I need to tell us is that in terms of physical property, the C2 to C4 of members of alkene are all gases. All of them are gases at room temperature. Meanwhile, C5 to C17 are liquids. Liquids at room temperature. Higher members, that will be from C18 and above, are low melting solids or just solids. Can they say solid? Solids. C18 and above are solids. That's in terms of physical properties. Now, in terms of chemical test, of course, alkenes decolorize bromine water. Bromine water. And they equally decolorize KMNO4. KMNO4. So they decolorize these two things. Should you see that in the exam? Which of these decolorizes bromine water? Alkene or alkyne. That's one property that alkenes have, and the alkynes also share it with them. They decolorize this or this. Potassium permanganate or bromine water. So that's how much I will tell you on alkenes, just like that. The main important aspect of this class or this video is the preparation. How do we get alkenes in the lab? How do we prepare alkenes? All right. There are a number of reactions that can give us alkenes in the lab. I will only just pick 2 or 3 and discuss in this video, so that in the next video I will continue. More importantly, it's important I tell you, or I draw my outline for this video. Okay. It's important I draw an outline. What are you going to expect in the exam hall as a student from this topic, alkenes? Is either the examiner asks you questions on reagents. Reagents that are used in carrying out 1 or 2 reactions. Usually in organic chemistry, when an organic compound A wants to change to a new compound B, it's going to interact with certain set of reagents. Those reagents are able to change the organic compound into a new compound. So that's what we mean by reagents. If you know virtually all the reagents in organic chemistry, you will not have much problem in organic reactions. But students usually have problem in organic reactions because they cram the reactions. How many of them will you cram? For example, alkenes now undergo numerous reactions. How many of them do you want to cram? So the best way is knowing the reagent that is capable of carrying out that reaction, and as well knowing what is going to happen in the reaction. And then another thing, there are basic principles, there are basic things in organic chemistry, such as electrophile, nucleophile, etc. All those ones, I'm going to drop them in the 4th videos that are coming. Like I said, there is a video I'm going to drop called Organic Chemistry for Beginners. So when you watch that video, it will help you a lot in organic chemistry. Not just for topics like this in alkenes, but many topics in organic chemistry. So I'm going to drop certain reagents here, and I'm going to tell you what these reagents are used for. All right. Of course, in organic chemistry, there are numerous reagents, but I'm just going to start by talking about the preparation of alkenes. How do we prepare alkenes? How do we prepare alkenes? There are a number of reactions that can give us alkene. Number 1 is called dehalogenation reaction. Dehalogenation reaction. Dehalogenation. Dehalogenation. When we use the word DE in organic chemistry, it means removal of something. You want to remove something from a certain set of compound to yield a certain set of organic compound. And dehalogenation is a type of elimination reaction. So this is one of the elimination reactions we have. Elimination. When we say elimination, we want to remove something from the organic compound to get a new compound. Dehalogenation. D, remove. Halogen. Halogen. Remove halogen from a compound. Now, the compound we normally use for this reaction is not every compound that have halogen that we use. Of course, in organic chemistry, the family of organic compounds that have halogen is usually the RX, the alkyl halides. Right? So there's one I'm going to draw now. 1, 2, 3, 4. Let me just leave it at 4 chains. Okay, I'll put chloro group here and chloro group here. Or in place of chlorine, bromine can be used. So if I give you this now as the starting material, the starting organic compound I'm going to use to prepare my alkene. All right. So this is it. Of course, if we have this compound, what do you notice here? This compound have 2 chlorine atoms now, 2 atoms of chlorine on consecutive carbon. That it is having 2 chlorine, 2 chloro groups, we will say that this compound is a dihalide. A dihalide. That the 2 chloro groups are on consecutive carbon, that is next door neighbor. This chlorine is here and this chlorine is here. So we are going to say that this is vicinal dihalide. So what are we carrying out? We carry out dehalogenation of vicinal dihalide. When we carry out this reaction, we are going to get an alkene. What is the reagent that we use when carrying out this reaction? It's usually zinc. In what class? In methanol. I want to caution students, this is zinc in methanol. Zinc in methanol is the reagent that we use when we want to carry out dehalogenation of vicinal dihalide. Of course, what are we going to get? We say we are preparing what class? Alkene. Of course, alkene will be our major product here. Now, it's important I tell students that zinc in methanol, you can see this in exam as zinc in any other alcohol. Sometimes the examiner might bring it like that. But precisely we use methanol more better than other ones. But should you see this as zinc in any other alcohol, it still means dehalogenation. That's why I talked about reagent. Reagent tells you what you're going to do in a reaction. And what do we say we should remove? We are removing halogen. That means I'm going to cut off this, and then double bond will enter here. That will be my product. So if I draw my product at this side, I'm going to have C, 1, 2, 3. That's what I have here. And then I have C. Then this chlorine is no longer there. I still have H here. That's H. And then double bond enters there. Double bond. This is no longer there. This is not there. Then C. Then this H is still there. H. Then with a CH3. All right. CH3. This is my product. If you name this product here, you are going to name it as boot for 4 carbons. 1, 2, 3, 4. Boot. If I number from here to here, or I number from here to here, is the same numbering. If I number it here, this will be carbon 1, this will be carbon 2. If I number from here, this will be carbon 1, this will be carbon 2. Anywhere I number it, the same numbering. Therefore, I will be having what as a name? Boot 2 in. Why? Because on carbon 2, there is a double bond. Double bond belongs to the carbon it first meets. That's how we do it in organic chemistry. Double bond belongs to the first carbon it first meets. And that's why we have boot 2 in. Class, this is the product of this reaction. We have successfully prepared an alkene from the halogenation of vicinal dihalide. Alright? Now, in terms of mechanism of this reaction, it is believed that this zinc is able to collect these 2 chlorine. So therefore, the side product I'll be having there is plus zinc collecting these 2 guys, zinc chloride. That is my side product. Should you be asked in exam, what is the side product of this reaction? So this is one way of making alkenes by dehalogenation reaction. Alright? The next one I want to talk about is dehydrohalogenation. Dehydrohalogenation. From the word dehydrohalogenation, what does it mean? Okay, I'll put it here. Dehydrohalogenation. What does it mean? Remove hydrogen, remove halogen. And 2 of them must come from a consecutive carbon. Let's look at this now. Let's say we have something like this. 1, 2, 3, 4. Of course. Okay, let me say I'm having bromine here. Br. And then H, 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 H. Of course, this will be 1 bromobutane. If you are to name this AIPA, this is 1 bromobutane. All right. if I carry out dehydrohalogenation on this compound, first of all, what is the reagent we use? The reagent we use for this type of reaction, this second one, we use potassium hydroxide, KOH, in the presence of ethanol. Ethanol is usually written as ethyl alcohol in short form, ETOH. Should you see examiner writing it like this, that's ethanol. Or sometimes it can be that KOH is on top and down on your arrow you are having it as CH3CH2OH. This is still ethanol. You can still have it as C2H5OH. Anyhow, this is the same. So, provided you're having potassium hydroxide in ethanol, that is dehydrohalogenation. Alright? Now, I want to write the product of this reaction. So, permit me to bring the product down, since I don't have space there. So, I'll bring my arrow down here, like this. So, I'll put the product of this reaction here. Now, what are we removing? We say we are going to remove halogen and hydrogen. And that two of them should come from what? Consecutive carbon. Meaning that if my bromine should leave this place, of course, there's no other place I have bromine here. My hydrogen should be coming from the next carbon. So that my double bond will be placed at this point. Alright? So what am I going to get as product from this reaction now? I'm going to have as product CH3, that's this. Then CH2, that's this one. Then I have C, double bond enters here, double bond with H. Is that not? Then here, of course, this guy is out. Then C and H and H. That's my product of this reaction. I have successfully prepared an alkene from this reaction. So this is my product. All right. This is boot for 4 carbons. 1, 2, 3, 4. Boot. Boot what now? Boot 1 in. Boot 1 in. Boot 1 in. That is my product now. Boot 1 in. I prepared boot 1 in from this compound by carrying out dehydrohalogenation. Now, let me just rearrange this original compound now and see what we are going to see now. Imagine this bromine we are to be here and this hydrogen goes there. Let's do that very quickly now. If we do that now, okay, so I'm going to be having something like this. Okay, let me bring it to the other side. Let me bring it to this side. So you can pause the video and copy out these reactions so that you can visit it again. Now, like I said, when you are faced with this type of question, this one is not hard. You already know that your bromine will come from here, while your hydrogen will come from here. What if we have another arrangement like this? 1, 2, 3, as I have. C, 1, 2. That's changing the compound now. Okay, 4 carbon atoms. So I have it like this. Let's assume that the bromine is now here. Okay, then there are H at all these points. Of course, let's look at this compound. Let's look at this compound. Now, if you are to name this compound, this is 2-bromobutane. You are now seeing that we are faced with a danger here. What is that danger? We know that if we are carrying out the hydrohalogenation with the same reagent, KOH in ethanol, KOH in ethanol, KOH in ethanol, then we know that our bromine will come from here. No argument at all. But where will our hydrogen come from? You now see that we now have two options. This carbon is consecutive to this carbon. Why this carbon is consecutive to this carbon? That's next door neighbor. Then our hydrogen can come from here or come from here. In real life situation, we are going to have two products for this reaction. Why one will be called major product, the other will be called a minor product. And now that we have this, should my hydrogen come from here or from here? That is where we now obey a certain set of rules. That rule is called the Saint-Zepf's rule. The Saint-Zepf's rule. Some texts may call it Zaitsev rule, the one that starts with the Z. All right, same name for the same person. So Saint-Zepf's rule is a rule that guides us when we want to carry out elimination reactions. When we want to carry out elimination reactions, we obey Saint-Zepf's rule. What does Saint-Zepf's rule suggest? Saint-Zepf's rule states that when carrying out elimination reaction, just like what we're having here now, that we should pick hydrogen from the carbon that have less hydrogen. To whom less is given, take more from him. Like suppress him the more. So if you look at this carbon now, this carbon is having how many hydrogen? 3 hydrogens. If you look at this one now, we are having 2 hydrogens. So where do we pick our hydrogen from? Of course, we're going to pick our hydrogen from here. Then that means our double bond will be introduced at this point. Of course, when we do that, we'll have both 2 as our major product. So we're going to have this as our product. CH3, that's for this. Then C, this H is still there, that one is off. Then H, double bond at that point. Then C, this guy is off. Then H, then bonded to what class? CH3, 1, 2, 3. If you name that compound, you will see that that compound is still what? Both 2 in. Both 2 in. Alright? Both 2 in. Now, that is the major product we get from Saint-Zepf's rule. But what if we disobey Saint-Zepf's rule? We would have gotten both 1 in. That's by picking my hydrogen from here. The product would have been both 1 in. But in real life situation, this will appear about 80%, while both 1 in, which is when I disobey Saint-Zepf, both 1 in will appear to be how many? About 20%. Just very small. Small amount, small quantity. So should you get a question that says, what is the major product in so and so? The major product is the product we get when we obey Saint-Zepf's rule. Alright? So that is much I can take in this video. At least I've prepared alkenes using 2 different methods. We said that the first one is what? Dehalogenation, while the second one is called dehydrohalogenation. Now, before we end this video, I'm going to list the set of reactions that alkenes undergo that I will talk about. But it's important I tell you that alkenes can also be gotten by the dehydration of alcohols. If you dehydrate primary alcohols, we are going to get alkenes. Of course, dehydration have, even from secondary school days, we know the usual reagent we use, H2SO4. So we use H2SO4 to dehydrate. Dehydration, D, removal of. Dehydration. To dehydrate means, like if I'm thirsty now, I will say I'm being dehydrated. So how do you supplement the water? By hydrating me. Adding water to me will mean hydration. Dehydration, removing elements of water from me. Remember that dehydration and drying are not the same. Drying is removal of water, while dehydration is the removal of the elements of water. So we'll see that in the second video, all right? Before I'll be talking about reactions. But before I end this video, I'm going to draw the list of reactions I'm going to take, reactions that alkenes undergo, I'm going to take in the next video. So number 1 reaction that alkenes undergo is oxidation. Alkenes can be oxidized. And number 2 reaction, okay, I will say ozonolysis, which is also a type of oxidation reaction. But this one has many peculiarities. And that's why we treat it separate. Alright? And then number 3, we have, there are so many reactions. Reaction with hydrogen halides. Reaction with HX, hydrogen halides. In addition reaction, where Markovnikov's rule may apply or may not be applied. So we'll see that very, very important reaction. And then number 4, alkenes can equally react with hypohalous acid. That is, they can react with chlorine water, or they react with what? Bromine water. So watch out for our next video. Our next video will carry out the reactions that alkenes undergo. If you ask me, What are the reactions that Alkenes and I will tell you many reactions. So, but we're going to treat the ones that are very, very important to us, which are these ones. We'll feature all these ones in our next video. Okay? So, thank you for watching. See you in our next video.